what does useClient do? So if you've ever seen React Server components, and you might have seen this directive called useClient. And I find that there's a lot of misunderstandings or misconceptions about what it actually means. If you think something along the lines of it marks a component as a client component, it's kind of true, but not really. I think especially for people who don't care about React, I think this post will be informative because I really want to dive into the underlying idea that is not React specific. It really has to do more with the module system, so features like import and export. Let's get into it. React Server Components famously or infamously has no API surface. It's an entire programming paradigm that largely stems from two directives. One is useClient and the other one is useServer. In this post, I'd like to make a claim that their invention belongs in the same category as the invention of structured programming, so I'm talking about conditions and loops. First-class functions, so the ability to accept functions as arguments or return functions as return values from other functions, and async await. And so the common thing between all of those three things is that we've taken a concept that was possible to do with the tools before. So before we had while loops, you could emulate a loop by having a go-to statement. So there was a statement you don't have it in JavaScript, but in some languages you do. You have this go-to statement that says go to line 20, and so that's how you did loops. But then we got a first-class way to structure loops, and that's called structured programming. And then with first-class functions, even if you don't have first-class functions in the language, you could still, for example, in C, you don't have first-class functions, but you could still have functions calling other functions, so people could get by. However, first-class functions are a lot more flexible, right? So we use them every day. We use, even when you pass something to array.map, you're passing a function to it. So this is an example of using first-class functions. So it really kind of made functions a first-class primitive in the language. And async await is kind of similar, and I'm actually linking to a post by Miguel de Icaza called Callbacks as Our Generation's Go-To Statement, which is a pretty old post. It was actually written in 2013. It's not about JavaScript, it's about C#. C# was, I think, the first mainstream programming language that added this feature. And before async await, you would write asynchronous code as this kind of nested doll of you write some code and then you say I'm gonna write a function that is that represents the rest of the code, and then like every time you want to await something you kind of have to nest these functions. And it doesn't mean that you couldn't write asynchronous code before async await, it just means that there was no first class way to do it. What I want to posit with this post is actually that useClient and useServer, they correspond to existing patterns like this that we've gotten used to that have no first-class way to represent them in the language. And so they put those patterns into the language. And so the patterns that I'm talking about, there are two patterns. One is a script tag, so that is what useClient corresponds to. And the other pattern is a fetch call, and that is what useServer corresponds to. The server needs to send some code to the client, and that is what the script tag does. And the client needs to talk back to the server to call an API or to send the form and so on. And so this is usually done by using a fetch. And so what I'm saying is that useClient and useServer are actually, you could think of them as a script or a fetch as a language feature built into JavaScript, which means that they actually, they can be typed with TypeScript, they're syntactic, so tooling can recognize them, and they really built this idea of a client-server application directly into your modules. Together, these directives let you express the client-server boundary within your module system. So they let you model a client-server application as a single program that spans the two machines, the two programming environments, but without losing sight of the fact that these are actually two different environments, so they may run at a different time, at different computers, and there's a network gap and serialization gap between them. And so this putting them into the language, so kind of putting the network as a first-class primitive into the language, enables some very interesting composition patterns. So I won't dive into them in this post. This is a link to my other post called Impossible Components. Maybe I'll do a video on it later, but for now, just trust me that it enables interesting things. Even if you never plan to actually use React Server components, I still think that you should learn about these directives and how they work, because they're not really about React, they're about the module system. I'm gonna start with useServer. I think it's easier to understand because it corresponds to a pattern that many are familiar with. Let's say you're writing a backend server with some API routes. So I have a couple of asynchronous functions that deal with my database layer that let you like or unlike a post, and I expose these functions as express routes. So you can imagine that these are express routes that just read the post ID from JSON and call my async functions and return some JSON. And I also have some front-end code that calls these API routes, and I'm not using any library to kind of, again, make the point this is not about React, this is really about the module system. And so this is just some plain vanilla JavaScript that, when I click a like button, it will see if you already liked the post. If you liked it, then it's gonna do a post to API unlike. So it's gonna go here, and then and get the likes count from the return JSON. Otherwise, if you have not liked this post yet, it will call the API like endpoint, which is here, and again get the JSON from it and use that JSON. And so this code is completely fine, but it is what they call stringly typed. And this is a link to this post by Scott Henselman called Stringly Typed versus Strongly Typed. The idea here is just sometimes you're in a typed language, so you could use types, but you're just passing strings around, right? Like it says, instead your types are stringly typed. You are passing strings around when a beta type exists. And what I mean by here is, like if you see, I'm doing like await, fetch, API, and like, but this is a string. There is no direct connection between this piece of code and this piece of code. So I need to kind of know that, this piece needs to be deployed on a certain machine for this connection to work. I need to remember not to change, the shape of the parameters that I pass and assume that I'm going to be able to read on the other side. I need to remember about the shape of this, that it has to match the shape that I get from this. So there's kind of this like implicit connection between these two separate programs, the client and the server, and I have to maintain these connections and remember that these strings are actually very special, that they tie them together. And so what we're trying to do here is we're trying to call a function on another computer. However, since the backend and the frontend are two separate programs, there is no way to express this connection other than a plain fetch. Imagine if we thought about the backend and the frontend not as two separate programs that kind of talk to each other, but instead as a single program that has been split between two machines. And so I kind of tried to illustrate this with these kind of edges. So think of it as a single program that happens to kind of be torn apart into two split pieces. How would we express the connection between those pieces in code? If we set aside our preconceived notions about how the backend and the frontend should be built, then we can remember that what we're really trying to say is we just want to call a function from another computer. So what the way I would want to express this is I just want to import like post and unlike post from the backend. But of course, and then I would just await them. But of course, that doesn't really make sense. And the reason it doesn't make sense is because like post and unlike post cannot actually execute on the front end, right? If you remember, they're reading from the database, and it's backend only code. And so importing backend only code into front end is by definition meaningless. We don't have any good meaning, that is assigned to it by the JavaScript semantics. However, suppose that there was a way to annotate the like post and unlike post functions on the backend as being exported from the server at the module level. So I'm using the useServer directive as a way to say, mark all exports as callable from the front end. So it's kind of like, we're exporting them as functions, but we're also saying not just export them to other modules that import it, no, like export it to another layer, or like, in a whole other computer being able to call them, like export them from the program, from the backend program, or the backend part of the program. And then if we did that, if we had syntax like this, then we could automate setting up the HTTP endpoints behind the scenes. And so now that we have an opt-in syntax for exporting functions over the network, we could assign meaning to importing them from the front end, because now we have a kind of well-defined thing that they could be doing, which is whenever you import something from the backend that has been specifically marked as being exported from the backend with your server, that means just give me a function that will do the HTTP call to the auto-generated endpoint behind the scenes. And that is exactly what your server does. I should say this is not a new idea. So I link to the RPC, or Remote Procedure Call, article on Wikipedia, and it says a remote procedure call is when a computer program causes a procedure or a function to execute in a different address space that is, different. It has a different global environment, different module environment. Basically, these computers don't share memory, right? Like you can't read the memory of one computer from the other computer. These are totally separate execution environments, but written as if it were a normal procedure call, without the programmer explicitly writing up the details of the network interaction. And of course, you might say, oh, this is a leaky abstraction. Calling the network is not the same thing as a direct function call. But this is why we have await, right? So we actually have all the tools in JavaScript where, if you want to handle errors from the network, that is just integrated with try-catch. So if you use await and use try-catch, you're going to get your errors. So we actually, I think, an async function expresses a network call pretty well, which is why we often, which is why you await fetch. And so this is just taking a step further and saying, hey, like this is a specific flavor of RPC for client-server applications where the server code can designate some functions as server exports or callable from the client, so parts of the server that are exported to the client. And then if you import like post, so if you import one of those functions while in this part of the program, so on the backend, it's just gonna get that function. So nothing special is gonna happen. However, if you import like post from the client code, so if you import them from this kind of bottom layer or bottom slice of the program that's gotten, that was torn apart from the backend. So if you import it from here, previously it wouldn't work at all. Like it didn't make sense to import backend only code into the client. But with this syntax, you kind of opted into saying, actually, whenever I try to do that, just give me functions that call these endpoints under the hood by HTTP. And so this is what it does. So importing like post from the client code gives you an async function that performs the HTTP call. And so have another look at this kind of Thorn program, and program a single program for two computers. So you may have some objections. Yes, it doesn't, if you don't explicitly expose an API again, you're not going to have a way to call this API from, say some other mechanism, right? Because the API endpoint are created behind the scenes, so you don't really know which route to post to. And yes, it requires some thought about how to version this, how to deploy this, how this is done under the hood, and it is kind of more implicit than writing a fetch. But really, if you adopt the view that the backend and the front end are a single program that is split across two computers, I think it's very difficult to kind of unsee this pattern, because now there is a direct and visceral connection between the two modules. So one thing you can do is you can add types now, right? So you could add post ID is a number, and then like post returns this object, and then because these are just imports, so this is export, this is import, TypeScript can actually see the direct connection that I'm here's what I'm passing, here's what I'm receiving. Like it connects these pieces together, and another thing that TypeScript could do at this point is it could verify that they're actually serializable, right? So they could verify that the things we're passing around are actually things that can be converted into JSON, and so they can be sent over the network. So suddenly, different tools we use can really understand the kind of the connection between the different parts of our program, even if they're running on different computers. And so that's pretty powerful. This is my favorite feature. So because these pieces are not directly connected, you can use control click or command click to kind of navigate into the function you're calling. So you could imagine you could press unlike post and you just teleport it in your IDE here. And similarly, you can take this function and you can do find all references on it, and it would show like here's where it gets called. So this is something you can't really do with API routes, like kind of written explicitly, because the IDE and your tooling does not understand the connection between these pieces of code. And this is why I was kind of mentioning structured programming and async await and first class functions as examples of the same category of features that create the syntactic connections, syntactic way to express something that was previously done by convention. So we are replacing convention with syntax here. And most importantly, you can now create self-contained abstractions that fully encapsulate both sides. So you can create modules that depend on one another, where a front end imports some corresponding backend logic, and so you have a single abstraction that kind of spans both sides without the need to create, without the need to worry about explosion of API routes they would have to register, because this server client split itself can be as modular as your abstractions. So there's no single global naming scheme for API routes. You don't really create API routes yourself. You just organize your code using export and import wherever you need them. The useserver directive makes the connection between the server and the client syntactic. It is no longer a matter of convention, it's within your module system. So useserver opens a door to the server code from the client. Speaking about the client, the second directive I want to talk about is useClient. Suppose that you want to pass some information from the backend to the frontend code, so kind of in the reverse direction. And as an example of that, you can imagine an old school express route that wants to render some HTML for a like button, and you want to render the like button itself, but you also want to attach some interactive logic, right? Like similar to the logic we had before, so that it actually does something when you click it. And so the browser will, the way we instruct the browser to do that is by sending a script tag referencing the front-end code. And so the browser will load that frontend.js file, and so this file will attach the click handlers, and this is how the entire program will kind of do the entire thing that it's supposed to do, is get some data on the server and then attach some interactivity on the client. And so this works, but leaves a few things to be desired. So one thing you probably want to fix is, you don't want to get an element by ID. You want to have many like buttons potentially, each with its own click handler. So you want each of them to receive their own data. So it would be nice to unify the display logic between the template in HTML here with the logic here, and kind of mash them together so that you could have many of those like buttons and each of them was independent. And so this is actually something that we already know how to do. So this, there's nothing new here. We know that we can do this with components. So we can create a React component, or you can imagine that this is not React, this is some other library, it doesn't really matter. But we can give name to this piece of code, and we can move the the like button, the fact that it renders a button, and its click handler somewhere here, and then we'll want to refer to it as a like button. And so for simplicity, let's temporarily drop down to purely client-side rendering. Of course, dropping down to client-side rendering doesn't mean that the server suddenly disappears. Like even if you don't think of the server as your job, the server exists. It's the thing that serves the script, right? Like it's where the HTML and the script is coming from. And so for now, I kind of want to drop down to, there is no button HTML tag here. This is an SPA. This is a traditional client only. The logic is all on the client. And so all we do on the server is just kind of prepare some data. Sure, we could have exposed an API route that does it, but if we're going to need to call that API, why not just put it into HTML? And so we have we render this script tag to get our front end working, and also we have to say, we want to render a like button into the document body. So this is this kind of an old school way of doing it is, we want to pass it some JSON, and then that's essentially our JSX that we want to mount on the client. So then the like button can appear on the page with these props. Again, nothing really new here. This is exactly how React used to be integrated in server rendered applications in PHP or Rails or what have you before the advent of client-side routing. So you would need to write the script to the page that has your front-end file, and also write another inline script that says, here's the initial props for your root component so that you can read them from your component. But let's think about the shape of this code for a little bit longer, because there's something curious happening, and you might have not noticed it, but the backend wants to pass some information to the front-end code, but the way we pass this information is again stringly typed. So have another look at this part. So what we seem to be saying is we want to have the browser load the frontend.js script tag, so the code here, and then we want to find the like button from that file. So that is a function declared in it, and we want to pass some JSON or some props to that component, and then we want to render it. So what if we could just say that directly in our code? So what if we say that on the back end we could say, hey, this thing here, like I want to instruct the browser, I want to generate the script tag that is going to take this component from this file on the client and pass this information to it. And right now I'm just talking about client-side rendering. I'm not talking about HTML. Like right now, we just want to generate these two script tags. I will return to HTML a bit later, but for now, imagine this is a spa. This is not a server rendered app. This is a spa, and I'm just saying, I want to pass some props to my spa from the server. So, what if I could just say directly, I want to create a script tag, and so the way I opt into that, because usually if I just import that like button on the back end, and if we kind of use the same semantics of import as what importing usually does, it gives us a function. But what I want to get is a script tag. Like I want to get information that lets me generate these script tags that let the client know which files to load and what information to pass to it. And so I'm just saying, what if I could mark this function as being sort of exported from the client to the server? So it's like this part of the program, this layer of our module system says, I want to receive props from the server. I want to be able to the server to render me as a script tag. I want to be referenceable by the server. And so we're taking a bit of a conceptual leap in this example, right? Like we used to generate HTML and now we're dealing with JSX, but stick with me. So what we're saying is these are still two separate runtime environments that we don't want to intersect, the backend and the frontend, but we're looking at them as a single program that kind of got torn apart. But we set up a syntactic connection between the place that passes the information, so in this case it's the backend, and the place that receives it is the front end. And this syntactic connection is an import because it's the simplest way to kind of specify, this is the place of code that I want to receive this information from the backend. And notice how, similarly to an earlier example where we gave new semantics to import, we gave it a different meaning than usually. Here too, importing from a file that's decorated with useClient from the backend, it doesn't give us the like button function itself. Because, if we got a function, like, that doesn't help us send it as a script. So instead, this gives us something else, which I'm going to call a client reference. So it's something that can be turned into a script and then sent to the front end. Let's see how this works. So this piece of JSX that I showed earlier produces this JSON, and this HTML tag corresponds to this part of the JSON, this body tag corresponds to this part, so this is just normal JSX. But notice that like button, the type, it's not a function, it's not the like button function, it's something we're calling a client reference. So this is a string, it could be an object, could be something else, but could be bundler specific. But you can kind of think of it as a almost the address of this function. It's like, how do you, the client needs to load this function because that's where all the interactive logic is. Like, the client needs to have it. So how do we tell the client how to load it? How do we generate the script tag? Like, this is just enough information to generate the script tag for it. And so we have the file name of the thing we want to load, so we can turn that into the script. And we have the name of the component or the expert from that file, so we also know which function to call, which function to pass the information to from our JSX. So that actually lets us generate the script tag that we previously had to write explicitly. And curiously, earlier I kind of I ripped out the server rendering, right? Like in the first example, I had a button HTML tag, and then I got rid of it. I just kept it as a SPA, as a client-side, fully client-side application that just loads a script and injects some data into it. But actually now we have enough information to also pre-render, this like button on the server to HTML, just its initial state. And this is not something that we have to do in this paradigm, right? Like, we could actually keep it as a SPA and just generate the script tags alone without the HTML. But we also have enough information, right? Like, we know which, in this client reference, we know here's the source code, and here's the name of the button, and then like the name of the export, and here's the stuff we need to pass to it. So if we wanted to, our layer that generates the script tags, which could be inside of a framework or something like that, could also run this code once and hand it the props, and then that's how it could optionally generate the initial HTML for it. Which is, if you've ever wondered why client components can execute on the server, but that's kind of why do we execute front end on the server? It's because sometimes we don't have to, but we can generate the initial HTML from the front end code, but it's still front end code. So the front end is still kind of a separate world. We can just pre-run it ahead of time, and that gives us the initial HTML in addition to all the interactivity that it's going to need later. So now that you know how this works, let's have another look at both files combined. So you can see that we're importing like button from the front end file or the client file, and in order for that to work the way we want it to, we have to mark all the exports of the front end file as renderable from the backend, right? So we want to say, I want to be able to receive props from the server. I want to be turned into a script tag. And so if you set aside your existing notions of how the backend and the frontend code are supposed to interact, you'll see that there's something special happening here, because the backend code references the frontend code using an import with useClient. And so again, we have this direct connection within the module system between the part of the program that is supposed to send the script tag and the part of the program that actually lives inside of the script tag that is being sent. And so I think like that kind of makes it more obvious why these are really two different environments. They, the part inside the script tag, it will run on another computer. There's no like shared variables between them. The only thing we can really do is pass information down from one computer to the other computer, but we can still express the connection between them syntactically, so that I can click on like button and kind of teleport into this part of the code base. I can right click on like button and say find all references and find this place in the backend code where it's being used, and essentially as a script tag. And we can even pre-render, so we can run the front end part ahead of time just to generate the initial HTML, even though we also plan to send it to the client to enable interactivity. So again, the backend code references the frontend code by using import with the useClient. So it expresses a direct connection within the module system between the part that sends the script and the part that lives within the script. And so because of that direct connection, it could be type checked, you can use find all references, and it's generally kind of exposed to your tooling. And so like useServer before it, you can think of useClient as sort of creating a door between the server and the client. So whereas useServer means that here's a piece of the server that's callable by the client through async functions, useClient means here's a part of the front end that is renderable by the server. This is the stuff that wants to receive props from the server. This is the stuff that wants to be renderable as a script tag. And so useClient opens a door from the server to the client. So it's like we have two worlds, and then we have two doors between those worlds. Okay, so now you see we're gonna have two different worlds, the backend or the server world and the front end or the client world, and we have two doors between them. You shouldn't think of useClient and useServer as ways to mark some code as executing on the client on the server. That's not really what it does. You can think of it as a way to create a door to the other environment, or to mark something for export to the other environment. So useClient exports client functions like button to the server so that it may render them as script tags or pre-render them to HTML. And useServer exports server functions to the client so that the client can import them and get async functions that perform HTTP calls to whatever things that we want to run on the server. And together these directives express the network gap itself within the module system. So they let you describe a client-server application as a single program that kind of lives between two worlds, and then you have these explicit ways to kind of jump from one world to the other with useClient and useServer. And I actually want to kind of draw this. There's one world, which is one JavaScript environment, and another world that is another JavaScript environment. So this is the server and this is the client. They may run at different points in time. They may run on different computers. They may run on the same computer if you're pre-rendering to HTML. So it's really, they're kind of flexible. This is where our like post function is, and this is where our like button is. And this is also where kind of our main backend is. And so when we want to refer from one world to another, we just use an import, right? But we can't just import things between the worlds. Like, it doesn't really make sense because these are different JavaScript environments. And so when we add useClient, we say, hey, if you import this thing from the server, you're gonna get a client reference that can be turned into a script tag, and that is kind of the shape of this connection. It doesn't actually execute any of this code. It just turns this into enough information to generate the script tag. And similarly, if you if we want to import like post from like button, we can do this, but we can't literally import backend code into the front end because we might use the database or something like this. But we can opt into that with your server, which means make this function importable from the client. Is just in this case we would get it would generate these async functions that you fetch over HTTP endpoints. And so we have this kind of like cycle or like two-way data flow. It's like one way, like the data flows down, and then if the user does something, the data can flow back up to the server, and then like we can kind of repeat the same process. It's important that this is not a leaky abstraction in the sense of pretending the network gap doesn't exist. In fact, it acknowledges and fully embraces the fact that these are two separate environments. They don't share any execution context, they don't have any shared variables. And so when you import stuff from one environment to the other and it has these doors, you don't get the real thing. You just get, kind of like a shim, either an async function that does this or a client reference that kind of like enough information to generate the script tag. And so they only really let each side only refer to code on the other side and pass information to it. And so really, like, the big reason why you would want to do that is because this lets you create abstractions that span both sides. So it lets you create abstractions like like a like button that has its own backend code kind of attached to it, and then whenever you use it, it will just have its it will have the API routes or whatever generated behind the scenes. And kind of similarly, it lets you have this like server code that has that can pass information to some client code and create abstractions that just span both worlds, kind of like full stack components. And so again, this links to another post that I've written that I haven't recorded the video about, but if you're interested in like what are some concrete things that you can do with it, do check it out. And so the server and the client are really, from this perspective, they're just two sides of a single program. They're separated by time and space, so they can't share the execution context and directly import each other. And the directives, they open the door across the time and space. So the server can render the client as a script, and the client can talk back to the server via fetch. But import is the most direct way to express those dependencies in code, and so the directives make the import work. And I kind of added this as a joke, but really, when I was thinking like, how do you describe this architecture kind of as a diagram that it's just like you have the server, you have the client, they're separate, but there are doors that let you kind of jump from one to the other. So I think that's just a very neat way to represent it. Thank you for watching and reading, and maybe see you again if this is something that you'd like to see more of.